Hey, thank you, Robin and Phil, for that great introduction to the Decadal. We're going to dive into a few of the separate chapters, and we're going to start first with chapter 19, which is the chapter about human exploration. So I co-chaired the Human Exploration Working Group, the HEXWIG, along with John Grunsfeld, who couldn't be here today, but sends his regards, and we worked very closely on this, along with the HEXWIG and the rest of the Decadal survey, especially the steering group. We just want to walk through some of the findings that you can find in here. And one thing to point out, it's important to note that for the first time, human exploration was really emphasized in the charter for the Decadal survey. And so this was in our statement of task to address this. And so this shows the importance that was put on human exploration for enabling this Decadal level science we've been talking about. So we were tasked with taking into account human exploration activities. And I'll just point out at the bottom, specifically asked, how can planned and potential human spaceflight provide new opportunities for planetary science? And then the corollary as well, where can planetary science inform human exploration? And so that's the science enables exploration and exploration enables science philosophy that we followed. You've seen this, so I won't dwell on it. You've seen it at least 3 times, but I'm glad in this meeting alone, Sarah Noble showed this, Robin and Phil just emphasized this. I'm going to show it again because there's very strong support within the Decadal survey for human exploration. And we're really trying to make the point that human exploration is aspirational and inspirational, and the Moon to Mars plans hold promise of broad benefits to the nation and the world. And so, as has been emphasized, we think that a robust science program can be the motivating rationale for sustained human exploration. And so we need to conduct Decadal level science as a central requirement for the human exploration program. We'll get into how we should do some of this in the next few slides, but we think the Planetary Science Division needs to have a strategic program to do this planetary science for the moon with an organizational structure aligning responsibility, authority, and accountability. And the Science Mission Directorate at NASA should have both the responsibility and the authority for integrating Artemis science requirements with the human exploration capabilities. And we'll talk about some specifics. Now, how are we going to do this Decadal level science? What do we need to do to get ready to actually execute? So you don't have to read this chart, but I point you to table 19.2. And we outline representative science, research, and development activities to enable and optimize high priority science from Artemis. So the Science Mission Directorate can take this as justification for some of these programs and activities that have already started and some that need to be ramped up and some that need to begin. Things that we have talked about in this meeting, cold sampling and curation, how you get those samples out of PSRs, take them out, collect them, contain them, transport them, bring them back to Earth, curate them, all of the steps. The sample science that we've heard so much about today. In situ measurements, what measurements do we need? What handheld field instruments do we need to do that? What are the CONOPS to allow the astronauts to take the measurements that we need? Writing out science requirements, going through landing site selection to optimize the science. We can keep going down the list, but there are a slew of activities that is the people in this room and that are online now that need to do to make sure we can optimize the science through human exploration. Now, in order to do this, we did a really deep dive looking at NASA's organizational structure. How do you incorporate science into human exploration? And we find there's 3 findings here. These are verbatim out of the report. We strongly suggest a systems engineering approach is taken to incorporate these science objectives and requirements into the early stages of mission planning and hardware development for human exploration. Because the later you start to integrate the science into these human exploration activities, the greater the risk of high expenses with trying to do this science and or the exclusion of priority science altogether. Another finding is that the way that Artemis has been structured in the beginning for lunar science has compromised the agency's ability to ensure we do this high priority Decadal level science because the requirements have not yet been adequately provided or incorporated into the human exploration architecture. So absent that, the science return from the first human landings in Artemis will not be as significant as they could be and may be minimal. So last finding here, without an integrated coherent strategy, it's unlikely that we'll achieve Decadal level planetary science. We can achieve lower level science goals until Artemis incorporates these top level requirements that are needed. So what are we going to do about it? So there's a few recommendations that are in the Decadal survey report for NASA to consider. The Planetary Science Division should develop a strategic lunar program, including human exploration as an additional option to the robotic missions to achieve the decadal level science goals at the moon. And also the second recommendation I'll highlight is NASA should adopt an organizational approach where the Science Mission Directorate has both the responsibility and the authority to develop Artemis lunar science requirements that are integrated with human exploration capabilities. Now, one way you could consider doing that is establishing a joint program office at the associate administrator level to develop these program requirements across the different directorates: the Science Mission Directorate, the Human Exploration Directorate, the Space Operations Directorate, Space Technology. And so I like to think about it as you've got all these directorates that have to work together, and they're all sort of at the same organizational level. And so it's having an office just above that, like the parent looking after the children to make sure they all work together and play nicely. And this is an eye chart, and it's intended to be. This was the crux of the issue. We did a very deep dive into the organization for Artemis as it stands. This chart was developed by our colleague James Keene. What you can see, you've got SMD on one side, you've got HEO in the middle, you've got the Space Technology Mission Director on the other side. It's very complicated. There's a lot of levels, multiple different organizational levels. There's also different colored lines, especially on the SMD side. That indicates where funding and management don't necessarily align. So one office funds a project and one other office has management responsibility, which causes some issues. One of the big issues that we saw is getting back to the responsibility and authority for having science requirements be integrated into human exploration. Because what you can see, there's a few dashed lines, if you look closely and squint, connecting SMD to the human exploration side. But there's no solid line where the Science Mission Directorate has the authority to impose requirements on the human exploration architecture. And absent requirements, and that's how things happen in the engineering world. So there are goals documents and objectives, and those are great starting points. But we're recommending that there is a direct line of authority where science can actually levy requirements on human exploration. Okay. I wanted to touch on ISRU as well, since there have been sessions and multiple talks at this meeting about ISRU. One of the findings here, and this echoes the talk that Clive Neal gave yesterday, a strategic plan is needed to identify measurements critical to informing ISRU architecture options to ensure sustainable exploration and the connection to decadal level science. So some of the key points is that we've talked about in the past couple of days, there is substantial overlap between the measurements you need to make for science, for understanding, potential resources, and the exploration applications for ISRU. You could have another finding is there could be an oversight structure to make sure we properly allocate resources to make sure that these are preserved in thoughtful ways for both science and for exploration uses. And then the third point is that NASA could benefit from convening a team of experts to look at the ethics of planetary ISRU. There are multiple white papers that were submitted to the Decadal survey, and we read them all about the ethics of ISRU. And so we need to take a deeper look at that. And so we have this finding we should bring a group of people together with varying topics of expertise to do this. A note on commercial vehicles. So we point out that the SpaceX Starship is on contract with NASA through the HLS program, the Human Landing System, to deliver Artemis crew to the lunar surface. And so we're looking ahead and seeing these commercial human spaceflight missions that will likely be coming online, both to the moon and to Mars. And they may provide unprecedented payload capacity and could offer tremendous opportunities for planetary science. These vehicles could potentially lower the cost of surface access and enable a new paradigm for how we do our science, how we test our technologies, and for human exploration. So in order to have the community thinking about how we can use these assets, there's a recommendation in the report that NASA should develop a strategy to utilize these opportunities to fly science payloads on these flights, whether they're uncrewed test flights to the moon and Mars and or crewed missions as well as those opportunities present themselves. So we've been saying there's lots of science that can be done by humans when they go to the moon. And so we wanted to point out some of the specific applications of that. So this is another table I don't expect you to read, but it's in the record. It's table 19.1. And we consciously looked at, okay, why are humans valuable? What is the human expertise? And so we listed that out and mapped that to science objectives, where the expertise of the humans on site is uniquely valuable to achieving science. And then we further mapped that to the priority science questions that Robin outlined that are in the Decadal survey, so that we can map what humans can do to this Decadal level science. And so one of the findings based on that is that a crucial driver for sustained human exploration is the ability of the humans that are on site with training and mission planning to conduct and enable the highest quality Decadal level science to expand humankind's understanding of Earth, the solar system, and the universe. So how do we do that? The recommendation is NASA should engage with the science community early and often to, one, define the science goals for human exploration, again, at the early stages of program planning, and two, ensure that the astronaut crews have the scientific expertise in field geology, planetary science, astrobiology, all the disciplines that we need in order to conduct that science. And I'll channel John Grunsfeld. He does say, just send a planetary scientist. Let him do it. Okay, so those are some of the findings from the Human Exploration Working Group. That's in chapter 19. And now I'd like to turn it over to Tim Grove and Brett Denevi, who were the co-chairs of the Moon and Mercury panel, and they will walk you through some of the lunar science.